This is a problem from one of my um, uh, examples that I do in my on-demand course, and we'll quickly work through this. I'm asking you to do a KCL to calculate the current I naught that is passing through this 2K resistor. Okay, make sense? So how will we go about it? How will we go about it? There are a few steps that are very important to take. Number one is to mark the nodes at which you are going to write KCL. Okay. So which points in this circuit will qualify as a node? Is this a node? Unique node? It is. Okay. Is this a node? It is. Is this a node? Not really, because there's no circuit element between these two guys. So these 2 points on the right are basically the same. Okay. This point and this point are basically the same. The reason that this point and this point are not the same is because there's a 2K resistor. The reason between why this point and this point are not the same is because there's a 3K resistor. If there's a circuit element, whether this is a resistor, where there's a current source or voltage source, it basically creates a new node. So what we need to do is we need to write KCL at these 2 points. Okay. The other important step is that you have to classify a reference point through a virtual ground. Now and you can pick any point for that, but as you can see that this will serve as a good reference point because this is a point where most of the branches, all the branches are actually meeting. So we can call this a 0 volt reference. Okay. Make sense? And then I'm going to start writing KCL at this point and a KCL at this point, and you will see that it will work out just fine. All right. There is no one correct assumption for current direction. In terms of current direction, if you want to understand like what should be the correct current direction, you can start off at a right footing by recognizing that the 9 volt source is probably pumping current into the circuit. This is the only voltage source over here, only power source. So if you ask me, Wasim, what should I assume for the direction of current going through this 3K resistor? I'll say it will be from left to right because on the left side you have a voltage source. Now, if this is the only current source, think about it like a water pump that is pumping current through the 3K resistor, right? And think about the 0 volt as a ground reference as a floor, right? So under the action of gravity, current will probably flow like this, right? It will all come back to the 0 volt reference. Does it make sense? Now, this is not the only current direction that you can assume. I invite you to go through another attempt of this circuit by reversing all of these directions. And I can guarantee you that your final answer when adjusted for direction will be exactly the same as mine. But intuitively, right, this makes a lot of sense. Agreed? Any questions, any concerns about this? So these are the directions that I'm assuming. That there is only one power source pumping current, and then from that point onwards, the current is branching out and returning back to the negative terminal of the power source or to the 0 volt reference over here, making a complete loop. Okay. All right. So this is how we're going to write these equations. So if I look at if I call this as B and if I call this as A, so VA and VB, right? So if I want to write an equation for I naught, knowing that this is 0 volt, okay, the ground reference, can you guys see that the delta V, VB minus 0 volt, so delta V divided by the 2K resistor is the correct equation for I naught? Any issues with this? Current will flow from a high potential to a low potential. That's what delta V is. V high minus V low divided by resistor. Correct? So the direction that we've assumed is this direction going down. All right. So this becomes VB minus V0, 0 volt divided by 2K. Any issues with this? That is one of the equations, unique equations that I can write. Okay. Now, when I'm writing the nodal equation, the KCL at point A, I have assumed that the current is entering through here and the current is actually leaving like this. Okay. And this is the 0 volt. So for the current that is entering this guy, all right, I am assuming that 9 volt is a higher voltage. So 9 volt minus whatever this unknown voltage is at VA divided by 3K. So this is the sum of current I in, okay, entering. And it should be equal, from the standpoint of this node, should be equal to the total of current that is leaving. So the two currents that are leaving are VA minus 0 divided by 6. That's basically the current through this branch. And then the other one is VA minus VB divided by 2K. So that's a current through this branch. Clear? That's my second equation. Now, this is where students make mistake. When they go about writing the nodal equation for the second node, what they end up doing a lot of times is that they reverse the direction. They're like, okay, you know what? Now I feel like the direction of this current towards left, this to the top, and this to the top as well. Please don't do this. That's where your assumptions have to make sense with the equations. Once you have assumed the directions, okay, they're frozen for this circuit analysis. You cannot just go back and forth. So this is the direction of current going from VA to VB. When I'm writing the nodal equation, I have to freeze this. Okay. The equations that I'm going to write will have to show these current directions. So from the standpoint of VB, the current that is coming in is this guy, which is VA minus VB divided by 2K. The current that is leaving, one of them is this one, which is VB minus 0 volt divided by 2K. Remember, we have a ground over here. And then the other one is this guy, VB minus 0 divided by 2K. All right. If you look at the set of equations that I have now and the number of unknowns that I have, how many equations do I have? 3 equations. 1, 2, and 3. 3 unique equations. How many unknowns do I have? How many variables have I used? VA is clearly one variable. VB is another variable. And I naught is another variable. So if I have 3 equations and 3 unknowns, can I go about solving them? Very easily. Your calculator can do that. You can use matrix. You can do hand calculations, back substitution, so many ways. From this point onwards, your job is done. The rest is simple math. We have 3 linear equations with 3 unknowns, and this is what your answer is going to be. Clear? Now let's say my direction for I naught was wrong. My assumption along the way was incorrect. You know, worst case scenario, what would have happened? I would have ended up with a negative sign in the final answer. And what that would have meant is that I simply need to flip the direction of I naught. Make sense? That's it. So if your assumptions are incorrect, and I invite you to flip all the current directions or few current directions, right? I can guarantee you that the worst case scenario will be that you will end up with a negative sign for your current. Then you have to bring about your knowledge and competency to use, recognize that this negative sign is not a big deal. All it means is that my direction or assumption for I naught was opposite. So I just need to flip the sign. Does that make sense? Now, what happens if your voltage has a negative sign? Does that mean that you have to make any adjustment? No. A negative voltage does not mean any manual interference, okay, or adjustment. Does it make sense? Only the current. If current has a negative sign, you flip the direction. If voltage has a negative sign, you leave it as it is. Now, as you can see, by going through this example, there were so many in between the line understanding, conceptual tests or curveballs that you had to tackle. Okay. And that's why students lose points on circuits despite thinking that, I've done something similar to this, I should be able to solve it. And chances are that A, B, C, D, the options that you're given, it's very easy to create option number C for a particular mistake, option number D for an incorrect assumption that you're not able to handle, option number B for an incorrect route or direction that you take. So even if you are able to select something from the given options, there's no guarantee that you ended up with the right answer. Okay, so that's our KCL. On-demand program, FE electrical, so you can see mathematics. Okay, I have lots of lectures, quizzes, lectures, quizzes, lectures, quizzes. So for each and every part of the specification item, algebra, straight lines is divided into a dedicated lecture and then a quiz. And within the lectures, you will basically find downloadable PDFs containing the key formulas, equations, and whatnot. Then you can use as part of your notes. And then when you go through the content, there are detailed explanations. I go to the conceptual overview and then practice problems, and then the quizzes with detailed solutions. And this is just math on the left hand side, right? So it's streamlined. It's a one-stop shop basically with all the resources that are available to you. And then I have time mini exams at the end. We were talking about circuit analysis, right? So let's jump to circuit analysis. So right here. So I have KCL, 19-minute lecture, calculator tutorial, explaining you how to go about solving the multiple linear equations, additional practice problems on KCL, then deep dive on KCL, right? KVL, I have a dedicated lecture, additional practice problems, series parallel equivalent circuits, Thevenin theorem, additional practice problems, deep dive. So this is all circuit analysis, right? I mentioned about computer sections earlier. So let's just jump ahead to computer sections. Even if you have zero background in computers, check this out. In computer networks, I have about 20 plus lectures. So if you're starting from zero reference, you can go through this content and rest assured that most likely you're going to be over prepared, right? And if you are weak in digital systems or any topic for that reason, computer systems, if you haven't taken computer, if you haven't taken software engineering or software course, then you can go through a bunch of these lectures as well. And then a full and computer simulated practice exam at the end. As far as the live training is concerned, the live training is starting on January 11th. And I have lots of students who are enrolling right now with the goal of covering at least a couple of sections before the live classes start. So I review the big 5 topics up front in the first 5 weeks. And in a fairly short period of time, by 30th of March, you're going to see that the entire 17 section for FE electrical and computer exam will be covered. And as far as the live training is concerned, the expectation is that students are basically going to be working through the topics of the week that I assign, lectures and quizzes, they complete them. I put together focus summaries for them that they can go through at 1.25, 1.5x. I give them weekly homework assignments on every single topic, and then study guide they can utilize as well. These are the crash course summaries. And then during the class, then we basically go through all of these topics in detail. And over a 12-week period, you're going to see that we'll be covering all the exam sections in a fairly efficient time. I also have a very active community. So as far as the support network is concerned, if you have any questions, you are not going to be stranded. You can always ask questions over here. You can, let's say you're operating in mathematics. If you have a question, you can post the question in mathematics, and you can see that students are asking questions all the time, very frequently, and they're getting responses from my teaching assistants and from myself in detail. Okay, so this student asked question 3 hours ago at 9:14 a.m., right? And the teaching assistant responded back at 11:13 a.m. with a detailed response. Okay, and again, same thing over here, and then I get detailed response over here. And this is broken out section by section, topic by topic. And even over here, you can see tons of success stories. Students are posting every Wednesday when they pass the FE exam, when they pass the PE exam, right? Yeah. And then as far as a P is concerned, I have a separate categories. You can, whether you're operating in general power engineering measurement instrumentation, whether you're operating in circuit, section 3, section 2, very detailed responses, and you will never be alone in terms of your preparation. As far as the P power program is concerned, let me just quickly show you. Remember I told you about the instrument transformers, that they are not even mentioned in the reference handbook. So when you check this out, part 1, instrument transformers, conceptual corner quizzes, okay? And then you have part 2, part 3, part 4, part 5, detailed explanations, multiple quizzes, and so on, okay? Check out the codes and standards section if you haven't already started your preparation. As I mentioned earlier, about 15 to 20% of the exam is contained there. So this is section number 1, by the way, on the left hand side. And these are not Mickey Mouse lectures, 34 minutes long. Some of them are 1 hour long, 18 minutes, 20 minutes, right? So NEC part 1 contains an overview, part 2, conductor sizing, part 3 is overcurrent protection, and then you have wiring, then you have junction box sizing, and so on and so forth, okay? And at the very end, when you come across protection, which is a topic that's missing in the reference handbook, tons and tons of details on that as well. And the live training program for the P power, same story. Starting on 11th of January, we're going to wrap it up 30th of March, and we're going to sequentially work through all of the sections, all of the topics, and basically get the job done. Typically, students schedule their exam within 3 to 4 weeks of the completion of the live training program if they're making use of the bundle. And that gives them the opportunity to do the practice problems, address the weak areas, do practice exams, sample exams, and gives them an idea of, opportunity to consolidate their learning.